where the 1, let's say this is equal to plus 1 if we want to send a 0, and minus 1 if we want to send a 1. And similarly, for user 1. And respectively for user 2. Okay, so that's great. We've boiled down, we've defined all of this. Here's our signal. We're just adding together the two users. We're adding together the two users' transmission. Both have coordinates +1, -1. So great. This is kind of the form that we had before, where we had one basis vector and another basis vector, and we had bits on each dimension. What's the problem? Yes? Yes. These modulation vectors are not orthonormal. They're neither normal nor are they orthogonal. So what we have to do is we have to orthonormalize. So the problem is S1 and S2 are not orthonormal. So what we have to do is we have to orthonormalize. So my orthonormalization procedure. So I'm going to orthonormalize to get an orthonormal basis. Sx and sy. That's my notation from before. So what do I do? The first thing I do is I take S1. I form Sx by taking S1. That's my first non-orthonormal basis vector. And what do I do to S1? Anybody remember?
Divide by norm.
Divide by the norm. So basically, if I only have one basis vector, all I have to do is normalize. Yeah. Cool. So what's the norm of S1? Basically, it's equal to the square root of S1 dot S1. So what's S1 dot S1? Basically, that's all of these coordinates added up. And you could say, we can break it down by chip. So what we can do is we can say, because we're adding together all of the individual, we're multiplying together all of the individual coordinates, it doesn't matter if I group by chip. So in other words, I'm dotting this chip with itself, this chip with itself, this chip with itself, and so on. So I have 4 C1s, so 4 times C1 dot C1 plus 3 times C0 dot C0, because there's 4 C1s and 3 C0. Square root of that. So C1 dot, excuse me, let's start with C0. C0 dot C0 is what? So what's C0? C0 is equal to this with length NC. So what is C0 dot C0? It's just NC. And C1 dot C1, what's C1? It's -1, -1. So C1 dot C1 is also NC. So this is then equal to the square root of 7 times NC. So Sx is equal to S1 divided by root 7nc. Generally, this 7, if the chip sequence were longer, this 7 would be replaced by 1 over LC. So Sx is equal to S1 divided by root 7nc. Okay, so that's the easy part. Now let's write S2, which is C0, C0, C1, C0, C1, C1, C1. And what we need to do now is we need to get Sy, which is equal to, okay, so what do we do first? We take S2 and we remove the part, so here's what we have. We have S1 and S2. So here's what it would look like in vector space. So we have S1 over here and S2. What we did with S1 was we normalized it. So now we have Sx, which is a unit vector in the direction of S1. What we want now, so we have S2, which has a component in the S1 direction and a component in the S2 direction. So the first thing we do is we want to eliminate the component in the S1 direction. That'll leave something that's orthogonal to S1, and then we normalize that, and that's S1. So first thing we do, we remove the component in the direction of Sx. How we do that? S2 minus S2 dot Sx times Sx. So this is the length of the component in the, excuse me, this is the length of the component of S2 in the Sx direction. And then we divide by the norm of the numerators. Okay. First question, what is this? So S2 dot Sx, what do we have? We have for one thing, Sx is 1 over root 7nc times S1, so that comes out of the dot product. So we get 1 over root 7nc times S1 dot S2. So this is a fundamental quantity. If you take two spreading sequences and multiply them together and sum over them, in continuous time what you do is you multiply them together and integrate. Here basically what you're doing is you're multiplying together all of the samples and summing over them, which is fundamentally the same thing. This is called the cross correlation. So it comes up here, it comes up quite importantly here, and it's going to come up quite importantly in the next step as well, in the second approach to calculating probability variance. So what is this? This is 1 over root 7nc